All right. So far in the class, we've focused primarily on cross-sectional data. So this is data where we have multiple units at one point in time. Then we've looked within cross-sectional data at categorical data. So when we have data that's best described as categories. And we've also looked at numerical data where we have things that are recorded essentially on the number line where the numbers themselves are meaningful. But what we're going to focus on today is what we call time series data, where instead of having data that has one index variable for multiple entities at one point in time, we have an index variable that's ordered through time, measuring one entity at many points in time. So this is sort of how we characterize time series data, where we're tracking primarily one numerical variable through time and measuring one entity. And typically this is done with numerical variables, although there's some nuance here, but you can essentially think of time series as measuring numerical data. So what we're going to try to ask today is essentially, are there trends or patterns through time? And we're going to construct visualizations that allow us to answer these questions. So we've looked at transactions at a coffee shop in a couple of our previous parts. What we're going to do today is look at coffee prices. So if you buy coffee, one of the inputs into making coffee is the coffee beans themselves. So we're going to ask a question of our data. What price would we expect in January 2026 of coffee beans? And I have this data set here. So you can see I have two columns. One is the date, where I have the year, I have the month, and then I have the day. This goes back pretty far. I'll show you the long history of this in a second. But then I also have price. So this is measured, just measuring the price. I believe this is by kilogram through each one of these periods. And so this is our question. How might we use this data to then give us a general idea of what price of coffee we should expect in January 2026? Okay, so the first thing we could do is just, we know this is a numerical variable, so we could just plot out a histogram of all of the prices, just to get a general sense of what the prices look like within our data set. And you can see we have this large, the most common grouping is, 125 to 150, somewhere around here. And I have this data set going all the way back to 1973, up until basically the present. But when we're looking at this data set, it's nice, it gives us a good indication of the distribution of prices. But for our question, this doesn't give us a lot of useful insight. Like if I were thinking about what to expect for January 2026, what should I expect? Just looking at this figure. And so you can already feel this isn't necessarily the right visualization to kind of summarize our data for our question. Maybe you pick the mode, the most common value. But it turns out we have more information in our data set that we could use to guide our question. And that's the ordered index. So we have not just an entity index like we do when we look at cross-sectional data, but we also have an ordered index through time. So what I'm going to do is actually just go through and plot out a bunch of points. So on the horizontal axis here, I have time. I'm focusing on 2021 for this visualization, but we'll expand in the next ones. So time on the horizontal axis, so I have all these months, and each one of these points represents a different day. And then on the vertical axis, I have coffee price. So this gives us sort of two dimensions, even though one of the the variables is just an index variable. In this case, because it's ordered, it gives us a little bit of extra information. So then the next thing we're going to do is use this information, the fact that they're in sequence, that this is one sort of object that we're measuring through time, to then connect the points together. So the fact that it's sort of one object that we're measuring, but recorded at separate points, means it's actually more meaningful to plot this as a line instead of separate points. It sort of visually tells you that it's one thing, just tracked through time. Okay, so do we notice anything specific about this trend? We can either have movements in the price that are positive, no change, or negative. So when I look at this and I'm thinking about trends in price, I'm going to just generally look at the pattern. So is there a pattern in the movement of prices? And what I can see here is generally at the beginning of the year, we have prices around 125. And then as time goes on, so as the sequence progresses, I see an increase in price. So there's not a lot of fancy ideas here. This is really just, now that we have a line plot, a scatter plot with time on the horizontal and then prices on the vertical, and then we've connected those points together to visually indicate that this is one entity. Now that we have this, we can then figure out what the pattern looks like. So here I see a positive trend during this one particular year. But we can also zoom out to get sort of a broader picture of what's happening, not just in this one year, but maybe a few other years. So what I'm going to do is just sort of zoom out and take a look at what's happening between 2000 and basically the present. And I think this gives us a more nuanced picture. When we had zoomed in on 2021, that was right here. And that was during a period where we saw prices of coffee go up dramatically. If you remember anything about that year, we had a lot of supply chain disruptions, which also impacted coffee. So we have trends, we have subtrends, so we can think about these trends within the trends. If I'm looking at this, the picture is much less clear than it was in the one specific year. Okay. So another thing we can do with time series, and you'll often see this with these kinds of time series, and I've seen it in GDP time series. You can actually plot regions where you have positive and negative trends using background shading. So this is just a quick little picture here. What I've done is isolate specific quarters and checked whether the price has gone up or gone down during these quarters. And here I've highlighted these gray regions for the quarters that see a decline in the coffee prices. Okay, so negative trends, I'm just plotting this with background shading. Not a lot of fancy things here, just a little picture that makes it a little easier to sort of identify sub-trends within a larger trend. So we're going to do a bit of this in exercise 1.3 with coffee prices. So we'll do that after we finish up here. Okay, so what have we done? Going back to our select, transform, encode framework, specifically for line graphs, our selection is really just looking at the coffee price interval that we're interested in. So here, I guess this should say 2000 to 2025. We're just picking the years that we're interested in. The main transformation here is just ordering the data based on its ordered index. Often the data you'll have comes pre-ordered, And as we'll see in the exercise, Python makes this very easy to do. Sort of by default, will give you a nice order. And then the encoding is, we're really just taking the date, putting that as the X position, and then the Y position is just the price. And then we're connecting the sequence with a line. So the line is just indicating to us that, that the data points are connected. Okay, so this is, sort of a narrow window. We're looking at 2 decades of data, but we can go back even further. And one thing with time series that we want to be careful with, particularly when we're dealing with prices, which is a pretty common thing in economics, is to make sure prices are comparable over long periods. So when you're looking at this figure, is there anything big that stands out? We're starting at, like the mid-70s, and then progressing all the way until the present. Do you notice any patterns or trends in prices during this period? Well, when I'm looking at this, it generally looks like prices are pretty flat. I don't notice any major patterns. There's a lot of variability, so sometimes prices spike and sometimes prices drop. But when I'm looking at this figure, one of the big things I want to think about is whether the prices, like whether $1 is worth the same amount today as it was in the late 70s. And that would make it easier to compare the two prices if we knew that they were comparable. And if you know anything about macroeconomics, which I don't claim to know a lot, you know that we have what we call inflation. So the price of the dollar can change over time. So we generally say the dollar in the past year is not the same as the value of $1 today or last year. So here what I've done is plot the original sequence. So this is all of the prices. And then I've plotted the value of $1 in 1970. So as this goes up, it tells us that $1 in 1970, it would be worth more today. So to get the same, to buy the same thing $1 would buy you in 1970, we have to pay more today, more dollars. And what's amazing to me is it's about $8 to buy something that would be worth $1 in 1970. Really pretty amazing. Okay, so what we need to do here to be able to compare prices of coffee through time is really just make sure that the prices themselves are comparable. So the main idea with this example is just that when we're thinking about time, we want to make sure that we make comparable the things that we're comparing on a time series. So what I've done here is just adjusted for inflation, which isn't a big thing we're going to spend a lot of time with in this class. But this is sort of a classic thing that primarily macroeconomists will do. Anyone doing sort of time period comparisons, we just want to make sure the things we're comparing are actually comparable. Okay, so here you can see after we've done the price adjustment, inflation adjustment, you can see the price in 1970s was actually much higher than it is today. And this was not obvious before we did the price comparison. So the trend generally after roughly 1980 is a slow decline in the price. And then after about 2000, prices seem to stabilize. And we're actually going to do this price adjustment in exercise 1.3, which we'll do next. All right, so what have we done here? The coffee prices we're selecting are really going back to the 1970s, 1980, up through today. And we also have this CPI data. I've done a bit of work behind the scenes to make this easy to do, but we have that in the data set as well. And then all we're doing to do this price adjustment is dividing this CPI adjustment factor by the prices. Okay, so then we're essentially doing the same encoding that we did with a line graph. It's just, in this case, we're using real prices instead of nominal prices. Okay, so going back to our original question, we were wondering what prices should we expect in January of 2026. So once I've highlighted all the nominal prices, which are not adjusted for inflation, and then I've highlighted the periods of price declines, you may try to scour this for patterns. Like maybe there's something specific that happens at the very beginning of the year. Maybe something weather related, maybe something like in the pattern of how we behave. Like maybe I buy more coffee in the winter because I don't have sun to sort of give me the boost of energy that I would in the summer. Lots of things we could think about. So when we're thinking about January specifically, we really should be considering not just the trend, but also are there seasonal patterns. Something specific about January. So what I'm going to do next is just take out all the data from January specifically and plot this on a bar chart. A box plot with a strip plot. So I have the box here. I have the median listed as the middle point. I have the minimum. I have the maximum represented by the whiskers of the box. And then I have the 25th percentile and the 75th percentile listed here. So I have 50% of my data inside this box. And then on top of the box plot, what I'm doing is plotting a strip plot. So this is just the specific prices themselves. The vertical axis here is meaningless. There's sort of variation vertically in the separate dots, but all this is doing is just allowing us to see better what the data looks like. This is what we call jittering. Okay, so this is just a picture of prices specifically in January. You may wonder whether there's something specific about January. Looking just at January doesn't allow us to answer that question, whether there's something specific about January that doesn't show up in other months. So what we can do is actually go through and plot box plots for each month. So here I've just listed January through December on the vertical axis. And then on the horizontal axis, I have coffee prices and each one of the months with a separate box plot. So what this does is give me an additional picture into variation within each one of the months specifically. So it sort of gives us a picture of whether there's something unusual about any of the months in time. So this is a pretty general question. So what I'm going to do is ask something more specific. In which month was the highest price recorded? And this box plot allows us to answer that kind of question. So here, for the highest price, we can just look at the upper whisker. So this upper whisker tells us the highest price in December, which is something like 2.2. And then all I have to do is go through and look at each one of these months specifically and try to find the one with the highest recorded price, which happens to be in April. I'm just looking specifically at the maximums, and that turns out to be April. Next question might be which season are prices most spread out? And to answer this question, I would just look at the range. So the difference between the maximum and the median. Sorry, the maximum and the minimum. So I've the range is listed out here. And the season with the largest difference between the maximums and minimums is like March through May. So like spring. You can see that here. So if I'm looking at the trend in the median price, one thing I can do is just highlight the medians specifically in the figure. So what I've done here is just highlight the medians. And if you're looking at these medians and asking about the trend, it's pretty difficult to see. Part of the reason is that there's a lot of variability in the maximums and minimums. So you can't really see a lot of this variation. It'd be better if we could zoom in. So one thing we could do is just plot out the specific medians themselves. So all I've done here is on the horizontal axis, I have the time. On the vertical axis, I have the prices. And I'm just drawing a line through the median price by month over a year. So this gives us a picture of the seasonality, specifically of the medians. Okay, so is there a difference between the largest and the smallest median price per pound? Well, yes, but what's the difference? So what I can do is just look at the maximum. This is, I don't know, something like 130. And then the minimum, which is like 121 or so, and then just take a difference. So this kind of question, it's sort of hard to see on the multi-box plot, but what we can do here with the line plot is just pull out the statistic we're most interested in. In this case, that's the median, and then plot that against time, which gives us sort of a better visual summary. Okay, so just to summarize what we're doing, we can see line graphs to show trends, so numerical variables through time, which is our main time series tool. We also have this background shading, which allows us to visually highlight subtrends. It's used sometimes, it's not that common. We also have a multi-box plot, which we used to show seasonality, so whether they're to show the variability within each one of the seasons. And then we do that across multiple periods. We're going to talk more about seasonality in exercise 1.3. But what we did with multi-box plots is we selected coffee prices, and we actually went back further than this. Then we grouped by month. We calculated the quartiles within in each group. And then the way we encoded this was using month as the Y position, and then using price on the horizontal axis. Okay, so that's the end of part 1.3. We have numerical variables, which we talked about in the context of time series. We don't generally do categorical variables in the context of time series. It's not impossible, but we just don't do it that often. And then we talked about a real price transformation, and then grouping by period. And then the main visualizations we used are the line plot and then the multi-box plot. All right, I'll see you in the next one.